So today we're going to do a lesson on sequences. We have a bunch of vocabulary in here that we will kind of get to piece by piece here. And we'll start off with number one here as we learn our first vocabulary word. Is the following sequence arithmetic? And what arithmetic means, it's basically a pattern of numbers in which the difference between two consecutive terms is the same. So for instance, 5, 10, 15, 20, and 25, the difference between them, like 10 minus 5, 20 minus 15, you take any term and subtract its previous one. The difference between those is always 5. And in fact, that is how we get the common difference in there. The common difference for that particular sequence was 5. So if I look at the one in number 1 here, we have 3, 5, 7, 9, and 11. Is there a common difference? And basically, remember, like I know that you guys can see that going from 3 to 5, it's 2, 5 to 7 is 2, 7 to 9 is 2, and that's great. So you know that your common difference is 2. But I want you to, it's not always that easy to see it in that way. And oftentimes people get the sign wrong if it's going down, that it should be, the common difference should be a negative 2 if it was going down by 2. So the strategy of always knowing what the common difference is taking any term, for instance, let's say the 9, and subtracting its previous term. So 9 minus 7 is 2. I could do the same thing. I could start with 11. 11 minus 9, and subtracting its previous term, is 2. 5 minus 3 is 2. So the answer is yes, it is arithmetic, and the common difference in this case is 2. And then we find the next 3 terms simply by adding that common difference. So we have 11 plus 2, which is 13, plus another 2, which is 15, plus another 2, which is 17. Okay, see if you can do the next one, figure out if that one is arithmetic, and if it is, what's the common difference and the next 3 terms of that one there. Okay, we should have found that it is an arithmetic sequence. If you made a mistake, if you said the common difference was 5, it's really important to understand that the common difference is negative 5. Again, 12 minus its previous one, 12 minus 17 is negative 5. 7 minus 12 is negative 5. 2 minus 7. If you subtract the previous term, you will get the common difference. Okay, let's go ahead and look at a geometric sequence now. A geometric sequence is a sequence in which the quotient between any 2 consecutive terms is the same. So in this case here, is this geometric? Is this sequence geometric? So what does that mean, the quotient? Well, the same way that I was subtracting by the previous term, this time I'm going to try dividing. So for instance, if I do 6 divided by 2, I know that that's 3. Does that stay consistent? Is 18 divided by 6 also 3? Is 54 divided by 18 also 3? Is 162 divided by 54 also 3? And the answer is yes. All of those has the same quotient between the 2 consecutive terms. So yes, this is geometric. What's the common ratio? The common ratio is what we did. Again, take any term and divide by its previous term. That is going to give us a common ratio of 3. All right, and then you're going to write the next 3 terms of the sequence, and you can do that simply by multiplying by 3. So take 162 and multiply it by 3, and then take those answers again and multiply them by 3 again. And when we multiplied all those numbers by 3, we got 46, 1,478, and 4,374. Okay, using that same process again, can you find if the next sequence is geometric? And if it is, what is its common ratio? Be careful about that one, and then write the next 3 terms of the sequence. So no matter which term I take, it's like 6, if I divide that by the previous term, negative 12, I get negative 1/2. If I take negative 12 and divide it by 24, I get negative 1/2. If I get 24 divided by negative 48, I get negative 1/2. Remember that I'm dividing by the previous term, so the common ratio is negative 1/2. Do not tell me that the common ratio is divided by 2. It's not asking you what you divide by. It's the common ratio is what you are multiplying by, and I'm multiplying by each time by negative 1/2. Then if I take the 6, the last term here, and I multiply it by negative 1/2, I'm basically taking half of 6, which is 3, but it's negative, so I get a negative 3 for the first term. Then I want to multiply negative 3 by negative 1/2, and when I do that, I get this work right here. All right, and then I take my answer there, which was positive 3/2, and multiply that also by negative 1/2, and I get negative 3/4. So these are the next three terms of the sequence. All right, so you're going to have this next one, number 5, you're going to have questions just like this on your test. And what people usually mess up is not following the directions well. This question actually asks you for 3 different things. First of all, whether the sequence is arithmetic, geometric, or neither, so you have to write one of those 3 words. Then, if it's arithmetic or geometric, then you have to state either the common difference or the common ratio, and you should be specific. If it's arithmetic, you should write common difference equals this. If it's geometric, you should write common ratio equals this. Then write the next 3 terms of each sequence. So there are 3 things that you're asked to find for each of those. Go ahead and find those for 5A through D. All right, so here's the answers to those. Notice that I put the answer to the first question in green, whether it's arithmetic, geometric, or neither. In red, I said what the common difference was and what the common ratio was. Which if it's neither, it's not going to have any answer to that one. However, even if it's neither, it's still going to have the next 3 terms because there is a pattern. For C here, I put it in yellow here. I noticed there was a pattern that from going to 1 to 2, I added 1 here. And then to go from 2 to 4, I added 2. To go from 4 to 7, I added 3. To go from 7 to 11, I added 4. So, oh, look, I see a pattern. I add 1, add 2, add 3, add 4. The next one's going to be adding 5. So 11 plus 5 is 16. Plus 6 gives us 22. Plus 7 gives us 29. That's how I found the next terms. Even though it wasn't arithmetic or geometric, we can still be able to figure out patterns and try to find things about them. Okay, so let's go ahead. This time we're going to make up some numbers here. So I would like you to think of a positive number in number 6 here and just put that number down into this area here. Okay, so put your number in there. And now you're going to make up another number, and we're going to call it the blue number just for the sake of calling it something. And you're going to put another number here. Okay, now I want you to add them together. All right. Then we're going to call this one here the second number. Every time we add blue to that number, we're going to call it the second number and the third number. Okay, now add the blue number to the second number. This gives us the third number. All right. So again, taking the blue number, adding that to this one should give us this one. All right, now write those first, second, third numbers in this order right here. Put those numbers down, first number, second number, third number here. And then write the next 3 numbers in that sequence here, right there. If you take... So if you take any number in that sequence and subtract the previous number from it, so take this number and subtract the previous one, or this one and subtract its previous one, or this one and subtract its previous one, you should get the same number. Write that in there. So what is the common difference in the sequence, since that's what you just found? Rewrite that here. And how does that common difference compare to the blue number that we started off with? We should have found that common difference, which we just found here, is the same as the blue number. We've been adding the blue number to each one of these, so that's what we're adding. And then when we subtract each one to find that common difference, we should end up with that same number. Okay, so now I'm going to ask you to go ahead and do the same thing for number 7, except this time make your blue number a negative number and see what happens when you do that. We should end up with the same thing, but I want you to go through that process, the same process through everything like that, and then see if you end up getting the common difference the same as the blue number when you get that at the end. Okay, now I'm going to ask you to, again, do the same thing. You're going to repeat the previous problem, but we're going to start off making the first number negative and the blue number negative. So try that same thing that you just went through, and this time you're going to start off making your first number a negative number, and your blue number is also going to be negative. Go ahead and try that same process. All right, we should have also gotten that the common difference is the same as the blue number. All right, then we're going to move into number 9 here. This time you're going to take a small negative number, and we'll call it the first number. Make it a very small negative integer. And now make up another small integer, and we'll call that the blue number here, and we'll put that here. And then you're going to multiply them together, multiply those two numbers together, and we'll call that the second number. And now you'll multiply, again, the blue number here by that second number to get this third number. And then you'll write the first, second, and third number here in order, and then write the next three numbers in that. And then you will take the number in that sequence, so any number in that sequence, like this one, and divide it by its previous number, or this one here, and divide it by its previous number. What number do you get? Therefore, you just found the common ratio in this sequence, which is what? How does it compare to the blue number? It should be the exact same number as your blue number in there, because we've been multiplying by that blue number all the way through. Therefore, when we divide any number by its previous number, we should get that blue number, which is the common ratio. Okay, let's do one more of those. This time, we'll again start off with a very small integer here, and we'll multiply it by 729. Okay, I'm going to, we'll call that, and then whatever we get here, we'll call that number you just put in times 729 gives us the first number. Now you're going to multiply it by 1/3, and you'll write the second number. To know how to multiply something by 1/3 on your calculator, you could also just divide it by 3. Multiplying by 1/3 and dividing by 3 does the same thing. So if you want to on your calculator, just divide by 3. And then take that number and multiply it by 1/3 or divide it by 3 again. Then write those three numbers here. And then continue with three more numbers in the sequence again. We're dividing by 3 each time or multiplying by 1/3 each time to get that. Now, if you take any number in that sequence and divide by its previous number, what do you get? You should be getting 1/3, which is the common ratio of this sequence.